My name is Tony Hodge. Welcome to Conversations about Mining and Society. Welcome, Dr. Mohsen Yahyaei, to our conversation about the digital mine. I want to talk about something that is utterly central to the mining phenomena, efficiency. Yes. Tell me about efficiency and why that plays such an important part. And what does it mean?
It means different things for different people.
That's the problem.
Yes. So when you talk with people in industry, they have different perspective about efficiency. Some of them, they think about throughput. Some of them, they think about cost. Depends on which level they are. Somebody, they think about energy. Some of them, they think about life of the equipment that they use. So there are all sorts of aspects in terms of efficiency. But the way I see it, I think it should be a combination of different things that you have to look at. And at the end of the day, it turns into the cost that you spend to produce that metal or the production that you're delivering to the market. But quantifying some of those costs is very hard to make it, check the efficiency of the process. Like for instance, if I'm looking into the environmental aspects, how I'm going to put the cost against those ones, because that's part of the efficiency of the process as well. I can make very cheap metal with very dangerous method and harm the environment. So yet my cost of production would be much less, but how I'm going to value that impact that I had to the environment. So those things, if they come to the play, then we have a kind of equation that we can say this is the efficiency.
Okay, let me now bring us back to the digital mine, because the digital mine is the flavor of the month, popular term across the industry right now. What is it, and what's its linkage to efficiency?
If you look into what digitization done to our life, it shows that there is a great potential for us to be able to quantify lots of these aspects that I mentioned about efficiency. And I think the key point in digitization is providing that platform that allows us to quantify the impact that our process has to different aspects. And I think that's the first step for us to be able to then put the value against them. Because at the moment, what happens is I have all of these aspects that I mentioned in terms of your mining cost, your processing cost, your environmental cost, your social impact costs. But because they are separate and we don't have a place that actually we can bring them together, so we can't quantify them. I think digital mine can help us to lay that platform.
So in fact, what you're saying is that it's partly, what I'm hearing is that it's partly to do with enhancing one's capacity to measure a phenomena, but it's also partly a capacity to do bookkeeping in a systematic way that allows you to bring all these things together in a clever way. Is that correct?
Yes, but that's already happening in industry. What is not happening on our digital money is about is to leveraging those platforms that allows us to bring everything into one platform, but then analyze them, learn from them, and then feed back those learnings to the process and change the way that we do the process. I think that's the loop that we try to close in our digital mine program, which when I did survey with different groups and mining companies and universities and OEMs that they provide these services, that loop is not closed yet.
Okay, so explain what you mean about bringing the whole system together and why that is so important, and the relationship between blasting and mineral processing and comminution in the middle at the bottleneck.
Yes.
Explain that, because that is really the essence.
Yeah, I think that you're correct, because actually comes back to the efficiency as well, because each of these steps that you said, at the moment they have their own team and group and department that they're working, so they are not connected as I've been
dreaded silo effect.
The key point is, if we can, with the digital mine, there's a layer that actually each of these departments or silos, they can feed from a platform. So they can maintain their silos. I know that it's very hard to break them, but they can feed from that. And the point is, what happens is, when we have that integrated connection that all of these groups, they connected to that layer, and we can analyze in a coherent method everything that we got, then we can learn from that. We can optimize the whole process as an overall process. Because at the end of the day, it's the whole from the beginning when you find the material in the ground and then extract it to the point that you produce the metal. All of that is one process. You have to optimize the whole. You cannot just optimize one part and one part and one part, because this is what we see every time. As I said, efficiency means different thing for each of these people. They optimize to their definition of the efficiency, and doesn't mean that that would be efficient for the next process and for the next process. But what happens is the guy in blasting, because it's much easier for them to dig the dirt from the ground and load it into trucks when it's finer. So what they do, they make a high intensity blast. They spend lots of money to do high intensity blast to produce finer fragmentation, because it's much easier to dig. From their perspective, that process is efficient because the wear of the equipment is less. They can dig more from the ground. They can deliver more tonnage.
And their KPI
is delivered
production.
Tonnage. Yes.
Delivered tonnage, yeah.
And then you come to the processing plant. You already bought, let's say, a SAG mill in the processing plant, and you want to run your process. But when you feed to the plant, you don't have those big boulders that you need for your SAG mill. Why? Because those guys, they wanted to optimize their process. And now this process is not optimized. But what happens is the milling processing, they have to deliver tonnage. What they say, okay, let's add balls in here, let's ground it and pass it to the flotation. What you do, you send a coarser material to flotation. Flotation, they try to use as much as reagent they can, they recover as much as they can, but they send and they have to use lots of chemicals in there to be able to reach to that recovery that they wanted. And then what happens, you send the tailing to the tailing dam, which now contains lots of minerals, first of all, and lots of deleterious elements in there and chemicals. And all of that caused because you want to optimize locally. But if I look to a whole process, thinking about my tailing, my separation, my comminution, and blasting, then I would come with a pattern in blast that actually is optimized for those guys as well as for my comminution process.
So the capacity for electronic communication between systems, between the individual platforms on an integrated platform, is not that new. I mean,
yeah, it exists. Yeah,
it exists for a long time. So what's the holdup? To me, it's not rocket science. Yes. What's the holdup?
And that's the struggle that we have in the digital mind, to identify what's the research bit in here. Because in a sense, everything is there. But what I'm thinking is, what is missing is for us to understand, if we want to do analysis of the overall process not at the processing level, one level above, which is like kind of a management level and executive level, what needs to be done? How we need to collect the data? What sort of data we need to collect? What sort of analysis we need to do? Because at the moment, most of the modeling and capability that we have is just focuses in the processing part. We don't have models or capability of modeling in an overarching sense.
Okay, the Sustainable Minerals Institute is a research institute that is on the bridge between the academic world of research and practical application. So let me ask you about something else, because you can have the models, the individual siloed models, or you can even have the integrated model, but at a certain point, it has to be done in the field. It has to be done at the operation. So if you can have all the lovely models in the world, but if this guy is being optimized and given an incentive through his KPIs, his key performance indicators, to maximize productivity of the blasting, this guy is being incentivized by the same thing for optimizing his little silo and so forth. So there's a management system that has to be in place that is consistent with what you're talking about. It seems to me that may be as much of an impediment as the integrated modeling. Now, I might be wrong on this. No, you tell us. Yeah, you've just come out of the field the last few days.
Yeah, I was in two different mines over the last 2 weeks. Yeah, I think you're right. That management part is important. But what we need to do is, if we can do those integrated modeling and show the value of what will happen if we change the KPI of each of these groups, then those people can start changing the KPIs for different groups to match those KPIs for the overall process optimization. Because at the moment we set wrong KPIs for each of them because we don't have that visibility. Yeah. But if we got the visibility over of the whole process, then we can start setting correct KPIs for each of the group. And that prevents us to optimizing in a sense that actually doesn't make sense for the next level. I think that's the key point. But SMI, in a sense, and UQ, because I've been talking with different groups at UQ as well, and I know now, after 1 year discussion with different people, that what's the available capability in UQ. I think we are very well positioned in terms of being able to have that overarching understanding. And as you mentioned, because we are practical people, we always go to field, we talk with people, we know how the process works at different levels, because the business school, if you look, they're talking with the executive level, we are talking with the processing guys. We have that understanding. I think we are very well positioned in terms of developing those overarching models, and also doing or delivering tools that help people to analyze the data and information.
So why is the digital mind a cross-cutting theme? This is a very technical area, you've just described it. Why is it a cross-cutting theme for the Sustainable Minerals Institute?
I think it should be cross-cutting because it goes beyond the technical parts that I was explaining. So we need to look into several aspects. So it's not only the process, the whole process itself. It looks into the business structure. It looks into the human factors into that. So those are the aspects actually it needs input from people as well. So if I'm looking into just only technology or techniques that we use in digital mine, everybody actually, they are delivering that. So there are lots of OEMs that actually they are way ahead of us.
Operating equipment manufacturers.
Yes. So these groups, they deliver those technology. They are ahead. But what is missing that we can deliver that is adding those other layers. Like what's the business structure is, how the business structure should be when you bring the digital technologies into your system. Because, there's an analogy we were talking the other day with one of the university professors in terms of nowadays, we don't have any people as a secretary that they have typewriters in front of them and they type letters. We used to do all of those in our computer doing emails. But there was a transition period in there. When you put digital technologies, it's going to change the process. And we have to understand how it's going to change the process. That's not come from the technical aspects. You need people that they understand the business, they understand the system of the process, and they can understand how to change that. At the same time, you can't remove the human factor from the whole process as well, from the whole equation. Human has play roles in there as well. How that human being interacts with the new system, how human being interacts with the digitization and digital technologies. So those are the aspects that actually we have to look into that. And it's not possible to do with one or two centers as like we deliver this project. So that's why it's a cross-cutting program.
Interesting. There's one thing you haven't mentioned, which I'm now going to open the door to, and that is you haven't said anything about worker health and safety. And I assume that the digital mine has major implications for that. So talk a little bit about that.
Yeah, that's going to change a lot. And I think it's started changing as well. I can see in terms of, there are several aspects. First of all, I think it's the training with all of these new technologies like augmented realities, holographic rooms, and all of those technologies. We can start giving more realistic training to people. And awareness to the people before they go to face real mine. The other thing is in terms of prediction. We can start predicting what's going to happen and prevent. With the new technologies, especially with the automation and robotics that we have, so we can start removing people from dangerous areas. There are lots of companies that have started to bring robots into the process, the areas that we know that actually we don't need people to be inside. So these are the aspects that's going to change the health and safety, or monitoring the health and safety of the people. So there are lots of activities happening in that area. But again, what I can see it's missing is start learning from those technologies and data that we collect and bring it back into the design of the process and changing the way that we used to do this stuff. So at the moment, the way I see it is we learn from this stuff, but still we keep doing this business as usual. So we can reduce the amount of danger to the people. We can reduce the amount of incidents that is going to happen. But we are not going to change the process unless we learn from what we collect. And the other thing is, to me, I think optimizing that whole process and make it more efficient will reduce the energy consumption at the same time as improving the metal production and reducing the impact to the environment as well. So that becomes important. We have to look into that optimization, but not only from the energy perspective. We should look into all of those aspects, I believe.
So, Mohsen, in this conversation, what is left a little bit vague for me is the relationship between your cross-cutting theme, the digital mind, and the other cross-cutting themes. Could you explain that a little bit, how you see it from your mind?
Yeah, so it's still is not very clear, but the way I can see it is we got 4 different cross-cutting programs in addition to the digital mind, that they are looking in different aspects. The digital mind could be the platform that actually each of these cross-cutting programs that can sit on top of that and start interacting with each other as well. Because in a digital mind, we can provide that communication platform for each of these groups, that the learning from them and understanding from each of the programs and the way that we change the business from each of these programs can come together and start interacting. To me, I can see it as a kind of a glue or cement that actually forms a concrete structure by adding those 4 and the digital mind together.
And I can certainly understand from what you're saying how, for example, the other cross-cutting theme on transformational learning or the cross-cutting theme on rules and governance and leadership, they do fit together. At the heart of the process is what you're doing. And thank you very much for telling us about it today in language that certainly most of us can understand. So thank you, Mohsen, very much.
Thank you very much.